Hi, hello, welcome back to my YouTube channel. So now I am going to tell you about Neymann Pearson's fundamental lemma, or else we can call it as a NP lemma. It is the most important question. So definitely you will get for essay. So without this question, the question paper will not be at all. So that much the question is important. Okay, so let me tell why this concept is used. This concept is used in order to know which sample is most powerful. For example, we take 10 persons who are using uh, call and another 10 persons who are using dolo. So we want to know which drug will work effectively. So one set is omega we call, and the other set of people are called as omega dash. So now we want to prove that which is most powerful, which will work effectively. So in that situations, to know the best, we have to use Neymann Pearson's fundamental lemma theorem. Okay, so if you go to any factory like that, if you want to select some goods, so you want to know whether which samples we have to take. So at that time this concept is used. Okay, yeah. So now let me tell you the statement. Let k greater than b be a constant and omega be the critical region of size alpha such that, so here omega is treated as what? Critical region. Okay, so omega equals to x such that s in the sense what? Sample. So we are taking one observation that belongs to sample, and that sample belongs to what? Omega set. Okay, so function x comma theta 1 by function x comma theta naught greater than k. Okay, or else you can write this statement as omega equals to x belongs to s such that L1 L0 greater than k. If one set is greater than, say, automatically the other set will be less than or equals to k. So that is called as omega 1, or else we can call it as a omega dash, or else you can call it as a omega bar. So you can indicate with any notation. Okay, so where L0, L1 are the likelihood functions of the sample observations. Here X we have taken now, so that means here we can have in a sample n observations under H0 and H1 respectively. Okay, then omega is the most powerful critical region to test H0 versus H1. Okay, so in order to prove which set is most powerful, we have to use this concept. Now let us prove this theorem. Okay, so in exam they won't give this statement. You have to write this statement. They just say that state and prove Neymann Pearson's fundamental lemma. They just give that one. So you have to write the statement by yourself. This whole full statement. Okay, so now let me explain the proof. Okay, so proof given that. So what they have given, we have to write. They give omega, omega dash, two sets they have given. No, so the two sets we will write first. Okay, so given that omega equals to x belongs to s such that L1 by L0 greater than k. So this is set 1, equation 1, and omega 1 equals to x belongs to s such that L1 by L0, so 1 is greater than, the other will be less than or equals to k. This is equation 2. These two are called as what? Critical regions. Okay, these two are called as critical regions. Okay, so now we have to prove that omega 1 is stronger than omega, or else omega is stronger than omega 1. We have to prove. Okay, so for that we have to take powerful critical region. Powerful critical region is denoted with 1 minus beta. So before that we have to prove that alpha also. Level of significance also, at which level it is powerful, we have to prove that one also. Okay, so first one, level of significance. First we are speaking only about omega. So alpha. So level of significance is denoted with alpha. So that equals to P of type 1 error. So alpha is nothing but type 1 error. Okay, so what is type 1 error? Nothing but here P of x belongs to omega such that h0 is true. So that means what? We are taking one observation which is belongs to omega where h0 is true. That means what? Null hypothesis is true. So that means this total probability belongs to which likelihood function? L0 likelihood function. Why? Because here we have taken null hypothesis. That's why this likelihood function also comes under null hypothesis. So that's why we have to denote it with L0 dx over the limit what? Omega. Okay, now why? Because here x limits we have to take. X limits belongs to what? Omega. So that's why here over omega we have to write. This is what? Alpha value. Okay, similarly what we have to do is power of the test we have to take. Sorry. Power of the test. So power of the test is denoted with 1 minus beta. So 1 minus beta is nothing but probability of x belongs to omega such that h1 is true. Now what we have to take is alternative hypothesis is true we have to take. Okay, so that means here, so this now which likelihood function we have to take? We have to take now L1 likelihood function. Why? Because alternative hypothesis will be in which likelihood function? L1. Why? Because here H1 we have denoted. So over the limits what? Omega itself. Okay na? So this is what? 1 minus beta 1. So in order to prove this Neymann Pearson's lemma, so what we have to do is, so in order to estimate or establish the lemma, we have to prove that alpha 1 less than or equals to alpha. That means one set is most powerful than the other. We have to prove that, or else this one can be written as alpha greater than or equals to alpha 1 also we can write. Okay, so both means the same. So now we have to establish this one. So till now what we did is we have taken only omega set we have taken here. Now we have to take another set that is nothing but omega 1. So let omega 1 be another critical region. Another critical region of size what? Alpha 1. Why? Because here we have taken that alpha 1 of omega is alpha size. Now omega 1 we have taken with size what? Alpha 1. Okay. And power of test. So what is the power of test will be? 1 minus beta 1. Instead of beta, we have to write beta 1. Why? Because we have taken another critical region. No? So that's why it is indicated with 1 minus beta 1. So now first we have to find out what is alpha 1. So that is nothing but, so level of significance alpha 1 equals to nothing but probability of x belongs to omega 1 such that h naught is true. Same formula, instead of omega we have to keep here omega 1, nothing but. Okay, so this is equals to what? L naught dx over the limit what? Omega 1. Okay, why? Because here we have taken the set what? Omega 1 critical region. Okay, so this is what? Alpha 1. So now we have to find power of test. So power of test is nothing but 1 minus beta 1. So 1 minus beta 1 equals to probability of x belongs to omega 1 such that h1 is true. Now we have to take what? H1 is true. Okay, so that equals to, so this is equals to what? L1 dx over the limit what? Omega 1. Okay, so now we have find out what 1 minus beta 1. Okay, 1 minus beta 1 we have find out. So now what we have to prove is we have to show that. So now we have to show that 1 minus beta greater than or equals to 1 minus beta 1. Nothing but we have taken here alpha 1 less than or equals to alpha, or else alpha greater than or equals to alpha 1. Similarly, what we have to show is 1 minus beta greater than or equals to 1 minus beta 1 we have to take. So for that we have to consider the Venn diagram. Okay, so what the Venn diagram is, this is set A, this is set B. Okay, so here A, B and this intersection is C. So this is omega 1. So from Venn diagram, let us consider from Venn diagram, omega equals to A union C. Omega 1 equals to B union C. You can call it as omega dash, omega bar. You can write instead of this. Okay. So next is, if alpha 1 less than or equals to alpha, so what we have to do is, what is alpha 1 value? This one. Okay. Integration over the limit omega 1 L naught dx. So integration omega 1 L naught dx less than or equals to, what is alpha value? Integration over omega L naught dx. Integration omega L naught dx. So what is the value of omega 1 from Venn diagram? Integration omega 1 is B union C L naught dx less than or equals to, omega in the sense A union C L naught dx. So now I am going to split this one. So integration B L naught dx plus integration C L naught dx less than or equals to integration A L naught dx plus integration C L naught dx. So the both values get cancelled. So the last remaining term is integration B L naught dx. So the remaining term is integration L naught dx. B we are having now. So integration L naught dx and integration A L naught dx. So integration less than or equals to integration A L naught dx. So nothing but this can be written as integration A L naught dx greater than or equals to integration B L naught dx. So this one is equation 3. So equation 1 and 2 are these two. Okay na? So equation 3 is this one. So now what we have to do is, from equation 1, what we are having equation 1? Equation 1, L1 L naught greater than K. This one we have to take now. So from equation 1, L1 by L naught greater than K, that implies L1 greater than L naught K. Okay. So now taking integration on both sides. Now taking integration on both sides over A, over limit what? A. So now integration A L1 dx greater than integration K is constant A L naught dx. Okay. So now what we have to do is, now see here L naught dx we are having. L naught dx we are having over the limit A. Here also L naught dx we are having over the limit A. But here the K is not there. So that's why what we have to do is, now multiply multiplied by k for equation 3. So what is equation 3? This one. So that means integration k into integration a L0 dx greater than or equals to integration k integration b L0 dx. So for this third equation we have multiplied what? K. So this is equation. So this is equation 4, sorry. So now this is equation 5. So from equations 4 and 5. So what we can write, if we think this is A and this is B, and again if we think this is B and this is C. Why we have taken this is B? In the sense, if you observe, these two are same. So finally what we can write is A greater than B greater than C. That means B value we have to write only once. From 4 and 5 equation we can write that one. So integration A L1 dx greater than k into integration over the limit a L0 dx. So next is greater than k integration L0 dx over the limit b. Here b we are having no? Here, okay na? So b. This is equation what? 6. Okay. So now from 2. Now we have to take the equation 2. Here we have taken equation 1. Now we have to take equation 2. So what is equation 2? Equation 2 is nothing but L1 by L0 less than or equals to k we have to take. So L1 by L0 less than or equals to k. So L1 less than or equals to k into L0. Now taking integration. Now taking integration on both sides. So integration L1, this set is omega 1, no? L1 dx less than or equals to k into integration omega 1 L0 dx. Okay, so if you see from Venn diagram, what is omega 1? Omega 1 means only this part, isn't it? So if we take this is omega, so omega 1 is nothing but only this part. That means what we are having? B. Only we are having the set B. So that's why what we have to do is here, instead of omega 1, we have to take B L1 dx less than or equals to k into b L0 dx. Okay. So now in order to get here a, why? Because from this equation, if you want to compare this equation, here b we are having. So which term, which limit we are not having here? A limit we are not having. So that's why what we have to do is, we have to consider this. See, this term we have to do what? We have to consider from this equation. This term is greater than what? This term, isn't it? Okay, finally, this term is greater than what? This term. So that means we can write directly, instead of this, we can write what? Directly this term. Okay, so that's why. So integration B L1 dx will be always less than or equals to what? Less than or equals to integration A L1 dx. So this one we have written from equation 6. Okay. So now adding integration C L1 dx on both sides. Why? Because we have to get omega 1. So omega 1 means here if you observe from Venn diagram, so C is common for both. So that's why we have to add here this term. So integration B L1 dx plus integration C L1 dx less than or equals to integration A L1 dx plus integration C L1 dx. So if we combine this one, what we'll get? B union C L1 dx less than or equals to integration A union C L1 dx. So B union C, A union C is nothing but B union C means omega 1 L1 dx less than or equals to omega L1 dx. So omega 1 is what? 1 minus beta 1. So less than or equals to 1 minus beta. Or else we can say that 1 minus beta greater than or equals to 1 minus beta 1. Or else we can say that alpha greater than alpha 1 also. Okay na? So this is about what? Neymann Pearson's lemma theorem. Hope you all understand. So if you get any doubt, please comment. I'll try to solve your doubt. And if you are newly watching, please subscribe to my channel for latest videos, and you also comment which type of videos you want. Okay, please like if you understand this concept. Okay, please like. So I'm seeing you are just watching the video but not clicking on the like symbol. So please click on the like symbol and also share with your friends. Thank you. Have a nice day.